Alright, this is Mr. Gillum, and today we're going to learn how to use substitution to solve real-world problems, like volume or exponential growth. But first I want to do a little practice with evaluating expressions with exponents in them as well. So if I want to evaluate this expression, and I know it's an expression because there's no equal sign and there's no inequality, and I want to evaluate with the value of x equals 3. Again, like we practice, I'm going to replace all the variables with open parentheses. And in this case, we have x more than once in the same expression. Now, you might be tempted to put the x squared with the 2x. However, those are different. Those are not like terms. Okay, we talked about combining like terms. In order to squish things together, they have to have the exact same variable part. And x squared is different than x, so we can't squish those together and combine those like terms. The value I'm going to put in for where the x used to be is 3. All right, and now I'm just going to follow my order of operations. So the first thing in order of operations is parentheses, and I see that in both of my parentheses there are no longer any operations inside. When I say operations, I'm talking about addition, subtraction, multiplication, or division. There's no operations inside the parentheses, so what I'm going to do is I'm going to go ahead and change that. And go ahead and remove the parentheses. Now, I have another problem here, and so the parentheses are gone. I'm looking for exponents, so the next thing I'm going to change is 3 squared. Remember, 3 squared is not the same as 3 times 2. 3 squared is 3 times 3, or 9. I'm going to rewrite everything else exactly the same way. Now the exponents are gone, and I'm looking for any multiplication or division. The first one I see from left to right, in this case, will be 2 times 3. So I'm going to say 9 plus 6 plus 3. Everything else stays exactly the same. And then, finally, since there are no multiplication or division signs left, I'm going to add and subtract from left to right. 9 plus 6 is 15, and 15 plus 3 is 18. So when I evaluate this expression, I get a final solution of 18. So we're using substitution the same way, but we're adding this added level of difficulty with the exponent. And so again, we have another one, a little bit shorter this time, and I would like to evaluate the expression x cubed minus 2, and I want the value for x to be a 2. So I'm going to go ahead and substitute the 2 in for the x, like changing a tire. I put in the 2, I take out the x. 2 to the third power is really saying 2 times 2 times 2, which we know is 8. 2 times 2 is 4, times 2 is 8. So 8 minus 2. In fact, I actually got a little ahead of myself there. There's no operations in the parentheses, so I can think of it as 2 cubed minus 2. My exponents come first. 8 minus 2 is 6. All right. So again, I'm just following order of operations through the problem and solving it. Shouldn't say so, evaluating it. Okay, one more. This time we have 2 variables, but the process doesn't change. I'm going to rewrite the problem with open parentheses where the variables used to be. And I'm taking out the variable and putting in the value. So in the first parenthesis, I want to replace that x with a 4. And the second parenthesis, I'm going to replace the y with a 2. All right, and now I'm going to follow my order of operations. So again, I notice that there are no operations inside the parentheses, so let's rewrite this like this. Okay, remember when a number is squished up against another parenthesis, that means there's a multiplication sign in there. It's just generally not written in there. I wrote it on the second line though for you. Now I'm following order of operations. I see that we have an exponent here with the 4. So I'm going to write everything else exactly the same way. And I'm going to change the 4 squared into a 16. 4 times 4 is 16. Now I'm looking for multiplication and division. The first thing I see is this 2 times 16. Everything else is going to stay the same. And I know 2 times 16 is 32. I still have some multiplication left, so I'm going to write everything down exactly the same way again. And I'm going to change the 2 times 2 into a 4. Now I'm looking finally for my addition, subtraction from left to right. The first thing that I see is a subtraction sign, so I'm going to do 28 plus 1. And finally, we know 28 plus 1 is 29. So when I evaluate that expression with the exponents, I know that it comes out to be 29. So the first real-world application we're going to use is volume for our substitution with exponents. And the volume of a sphere is represented by the expression below, where r is the radius of the sphere. I'm going to underline that because that's important so you know where to put each number. So the r variable is the radius. Okay, so when it tells us the number for radius, we're going to substitute it for r. You may or may not be familiar with this symbol. It's in the back of my room on a poster. It's called pi. And pi is an irrational number. It goes on forever, but we have an approximation for pi, and we're going to call it 3.14. So I'm going to substitute the decimal 3.14 in for pi. It says find the approximate volume of a spherical rubber ball with a radius of 2 centimeters. Radius of 2, use 3.14 for pi. Okay, so I'm going to take this expression, 4/3 pi r cubed, and I'm going to substitute in two things. The first thing I know that pi can be substituted for is 3.14. So I'm going to write it as this, 4/3 times something for pi times something for the radius to the third power. And for pi, I'm going to put in 3.14. And for the radius, I'm going to use 2. It says that r represents the radius in the problem, so I know when it says the radius is 2 centimeters, I can plug a 2 in for the r. I think I might need a little more extra room for this problem. Okay, that'll be good. And so what we have here is we're just working with this part now. And we just have another order of operations. What I want you to remember is that a fraction bar is the same as a division sign. All right, so this fraction bar here is the one I'm talking about. This fraction bar, that means division. Okay, and so when I follow order of operations, I first check for parentheses, and I see parentheses, but I don't see any operations inside of them. So I'm going to rewrite this problem as 4 divided by 3 times 3.14 times 2 to the third power. And this will be the first day that we're going to use our calculator for calculation, because we are practicing a substitution problem, and we've already practiced multiplying with decimals. So before I get ahead of myself, I guess the first thing we should do now that the parentheses are gone are the exponents right here. So I'm going to go ahead and underline that, or 2 cubed is the only thing that's changing. So I'm going to say 4/3 times 3.14 times 2 to the third power, which we said earlier was 8. All right. And so now what we have here is there's no addition and subtraction, it's all multiplication and division. And it's important to keep in mind that a fraction bar is the same as division. So now what I'm going to do is I'm going to take out my calculator, and I'm going to do my 4 divided by 3 first, because that's the first thing I see from left to right. When I type in 4 divided by 3, we're going to go up here. 4 divided by 3, it gives me 1.33333, on and on and on. Let's go ahead and just round to the nearest hundredth. So what I typed in my calculator was 4 divided by 3. Okay, and that gave me 1.33. That fraction bar means the same as a division sign. All right, so that's the first operation. Everything else stays exactly the same. Times 3.14 times 8. Now it's just multiplication. And again, we're just using our calculator now. I'm going to take 1.33 times 3.14. 1.33 times 3.14. The answer that I got from my calculator was 4.1762, and I still have my multiplied by 8 on there. All right, and again, today is the first day I'm going to let you use your calculator for specifically this assignment. But I just want you using your calculator on problems that involve pi. Okay, I would like you still to do the other problems without your calculator. So now the last thing to do would be 4.1762 times 8. And I would know that that's 33.4096, and again, that is used by calculator. All right, so problems with pi, you may use your calculator for today. All right, so 33.4096 would be the approximate volume of a rubber ball. And you may or may not have learned this before, but I think in Study Island it labels it for you. When we talk about 3 dimensions, our units are cubic units, so we call that centimeters cubed, or cubic centimeters is how you would pronounce that. Okay, so it's just a substitution problem, but it's got a real life meaning. So we're going to use our calculator whenever there's the use of pi, so that we're not spending all day on our substitution problems. I have another example here that's an exponential, which you'll learn more about in the coming years. And this time it says the number of bacteria present after the number of generations, so n represents the number of generations, is this expression where I is the initial number of bacteria. Okay, so the n number represents how many generations, and the I number represents how much bacteria there are. In this problem, it says that there are 10 to the third power bacteria present initially. So that tells me, that underlined in red tells me that I must equal 10 to the third power. Then it asks, how many will there be after 2 generations? That 2 generations, if I look back up here, we know that n represents the number of generations. So we're going to say n equals 2. So you have to do a little bit of reading today to know which numbers to plug in for which variable. Again, it says n is generations, and it also says that I is the initial number of bacteria. So I knew when it said initial bacteria, 10/3, and I knew when it said after 2 generations, it would be 2 for n. So I'm going to take this expression, 2 to the n power times I. I'm going to substitute in my values. So again, 2 to the power of 2 times 10 to the third. All right, and I'm going to scroll down on my screen a little bit here again. Oops. And maybe. And we're going to continue this problem on using order of operations. Now, I see parentheses here, but I don't need them because there's no operations inside. I take that back. There's no operations inside this parenthesis, so I can change it to 2 to the second power. And there is an operation inside these parentheses, and that's 10 to the third. I know 10 to the third would be like 10 times 10 times 10. And 10 times 10 is 100, and 100 times 10 would be 1,000. All right, now since there's no operation left inside this parenthesis, I can remove that parenthesis as well. 2 squared times 1,000. And now my exponents, 4 times 1,000. And then my multiplication, 4,000. So I know there would be 4,000 bacteria present. All right, so just another substitution problem. But you have to do a little reading to know what to substitute where. Okay, then finally, gravity. And this is an actual formula for gravity here. Including gravity, I should say. The formula for the distance traveled in meters, d, for an object falling for t seconds is shown below. So first things first, I'm going to label this one for you. D is how far it goes. So we're going to call d distance. And it's very convenient that they called that variable distance because it starts with a d. And t seconds, obviously, that's going to represent time. How much time has gone by? It says use this formula to solve this problem. Dahlin dropped 2 tennis balls from the same height. He measured how far the first tennis ball had traveled after falling for 4 seconds. Okay, so I'm going to stop right there, and we need to do that as well. So I'm going to start with plugging in 4 for t. And then it says he measured how far the second tennis ball had traveled after falling for 5 seconds. So the second problem, the second part of the problem says the time is 5. How much farther had the second tennis ball traveled than the first tennis ball? Well, to figure this out, we need to know how far each tennis ball traveled. So again, on this problem, we're going to go ahead and use a calculator. We have some decimals here. That would be appropriate to use a calculator in this instance. So for the first part, we're going to use 4 as t. So the distance would equal 1/2 times 9.8 times 4 squared. Okay, and so we're just going to figure this out until we know the distance. The second part of the problem asks us the same thing, except for this time, the time is 5. So we're going to write the same exact equation down, but we're going to, instead this time, we're going to use the number 5 for our time. All right, and we're going to try to figure out what that distance is. And because I'm kind of running out of time here on my presentation, I want to keep it under 15 minutes. I'm going to pause it, and I'm going to do a little calculation here, okay? Mr. Gillum did some work to do through order of operations and found that the first distance after 4 seconds was 78.4 and the second distance was 118.75. The question asks us how much farther had the second tennis ball traveled than the first tennis ball. So what I'm going to do is figure out whatever 118.75 minus 78.4 is. When I did subtraction, I found that it was 40.35